welcome back to My AI Edge, where we dive into the latest in tech and AI trends. Today, we're tackling a topic that's critical to the future of AI and the planet. We're talking about the environmental and economic impact of scaling AI models. It's all about the balance between progress and sustainability, and whether quest for bigger, better AI could be creating bigger, harder to solve problems along the way. So let's get into it. If you followed the world of AI, you've probably noticed the trend of bigger and more complex models. But while these large-scale models can achieve some impressive feats, like generating human-like text, creating complex images, and even making predictions in science, the question that's surfacing more often is, at what cost? According to recent insights from researchers, we're starting to see diminishing returns from scaling AI. Essentially, as we add more data, more layers, and more parameters to these models, the improvements in performance are shrinking. So, while we're pumping in more energy and resources, the gains in model accuracy or functionality aren't always keeping up. This trend has some researchers questioning the idea that bigger is always better when it comes to AI. For instance, Dr. Arvind Narayanan, along with others, points out that we may have reached a point where scaling isn't the golden ticket we thought it was. In fact, it could be holding us back. They argue that instead of focusing on model size, we should look for smarter, more efficient ways to use AI for specific tasks. And this brings us to one of the biggest challenges of scaling AI: energy consumption. Larger models require vast amounts of computational power, and that power needs a lot of electricity. To give you some perspective, training a single large language model from scratch can produce as much carbon dioxide as 5 cars over their entire lifetime. That's not just one training run either. Some of these models undergo training and retraining to improve their accuracy. This adds up, and we're left with a hefty environmental footprint. The hardware involved in training and running large-scale models also contributes to this impact. The specialized GPUs and processing units used in these models have a limited lifespan and produce significant electronic waste when they're eventually replaced. Not only does this waste take a toll on the environment, but it also adds another layer to the overall cost of AI. This massive infrastructure demand creates a barrier for smaller companies and researchers who often don't have access to the same resources as tech giants. This means the field of AI could become less inclusive, with only a handful of players able to build and deploy these mega models. But is there a way forward? Researchers like Meredith Whittaker are exploring alternative paths. They're advocating for a new focus on right-sized models, essentially smaller, more task-specific AI models that can often perform just as well as their large counterparts for certain applications. The goal here is to rethink how we approach AI problems. Instead of pouring all our energy into making the largest, most powerful model, maybe it's time to focus on designing models that get the job done efficiently. For example, rather than using a massive language model to handle customer support queries, a smaller specialized model could be trained on a limited dataset specific to that use case. Not only would this use fewer resources, but it would also deliver better, faster results for that particular task. On the environmental front, some companies are experimenting with ways to reduce their carbon footprints. This includes exploring renewable energy options for powering data centers or even offsetting emissions through environmental projects. But there's no denying that the energy demands of large-scale AI are an ongoing issue that needs to be addressed at every level, from how we design and train models to the infrastructure that supports them. Now, this isn't to say large models don't have their place. They've achieved some incredible things and are driving innovation in areas like medicine, weather forecasting, and even space exploration. But moving forward, it's about balance. It's about building AI that respects our planet's limits while still pushing the boundaries of what's possible. So what